Welcome to AI Tech Book. This is your Claude Certified Architect Prep, Domain 1, Agentic Architecture. Today, the agentic loop, the while loop keyed on, stop reason. Let's get into it. 2 agents, 2 implementations, 2 failures from opposite directions. The first loops forever. It calls the Claude API, gets back a response with empty content, feeds that empty response in again, and calls the API again. It never stops. No error. No crash. Just an agent that spins until something kills it from the outside. The second silently loses state. The model sends a pause signal mid-turn. It is. Partway through a long operation. The developer's code doesn't recognize that signal, throws the response away, and starts the next call fresh. Half a turn of work. Disappears. The model starts over. The caller gets a partial result with no indication. Anything went wrong. Neither agent crashed. Neither threw an exception. Both failed. Same root cause, a stop reason value the code did not handle. The Claude Messages API returns a stop reason on every single response. 7 possible values. For each one, there is exactly one correct action. Miss one, you get failure. Number 1 or failure number 2. Here is the first thing to understand about building an agentic loop. The model does not run continuously. It answers once and stops. Every time. You call the API. The model processes, generates, and returns a response with a stop reason. Then it is done. It is waiting. What happens next, whether there is a next call at all, is entirely decided by your code. The mental model. The loop is yours. The model is stateless. Every iteration looks the same. You send the full conversation history, every message. From the start, and you get back one response with one stop reason. The model has no memory of prior calls unless you send them as context. There is no persistent session between calls. The API is stateless by design. So the agentic loop is structurally a while loop. Build the message list, call the API, read the stop reason, branch on it, update the message list, call again. That is the entire architecture. Every agent in every language, in every framework, is doing exactly this under the hood. The stop reason is the switch. It tells you where you are in the agent's work. Your code tells you what happens next. On the exam, when a question shows you a broken agentic loop, the question is always, which stop reason was returned and which branch did the code take or fail to take? 7 values. For each one, there is exactly one correct action in your loop. First, end turn. The model reached a natural stopping point. It is done. Extract the result and exit the loop. Second, max tokens. The response hit the token limit, either the parameter you set or the model ceiling. The work may be incomplete. Handle it. Retry with a smaller request or exit. Do not silently return a truncated result. Third, stop sequence. You configured one or more custom stop sequences and the model generated one. This is a deliberate stop. Exit the loop on your configured condition. Fourth, tool use. The model invoked one or more tools. It is waiting for the results. Execute the tools, append the results, and continue the loop. This is the main driver of most agentic work and has its own mechanics coming in the next scene. Fifth, pause turn. A long running turn was paused mid-flight. The model has partial. State that it needs back. Append the response and continue. Do not start fresh. 6th, refusal. Streaming classifiers intervene for a potential policy violation. Handle it gracefully. Exit the loop. Do not retry blindly. 7th, compaction. The conversation was compacted to fit within context limits. The model knows. Just continue the loop. The API handles the compaction transparently. A note on the count. The stable API documents 6 of these. Compaction is defined in the extended API bindings and is included here because the exam tests the complete. Operational set. A further value, model context window exceeded, exists in some SDK. Bindings as a state distinct from max tokens. Know them all. 3 values drive continuations, tool use, pause turn, and compaction. Your loop keeps going. 4 exits. End turn, max token, stop sequence, and refusal. Your loop stops. The stop reason tells you where you are. Your code decides what happens next. Tool use is where most of the real agentic work happens. When stop reason is tool used, the model has requested one or more tools. It is holding onto its reasoning. It cannot finish until you execute the tools and return the results. Here is the 3-step cycle, and the one invariant that trips nearly every first implementation. Step 1. The response content includes one or more tool use blocks. Each block has 3 fields, an ID, a name, and an input, the arguments the model wants to pass. Extract these. Step 2. Execute each tool with the given input. Capture the result. If a tool fails, capture the error. You will return it to the model either way. Step 3. Build the next API call. This is where the invariant lies. You must append 2 things to your messages array in exactly this order. First, the assistant's response as an assistant role message, the one with the tool use blocks. Second, a new user role message containing tool result blocks, one for each tool use block, each matched by the tool use ID field. The order is not optional. The messages API enforces strict role alternation. User, assistant, user, assistant. If you skip the assistant message and send only the tool result, the API returns an error. This is the single most common tool use implementation mistake. A note on parallel tool calls. The model can request multiple tools in a single response, multiple tool use blocks in one content array, execute all of them, return all results in a single user message. Parallelizing the execution cuts turn latency by up to 90%, according to Anthropic's own benchmarks. Same 3 steps, same invariant, just more blocks in each message. When a tool use loop hangs, run through this checklist. Did you append the assistant message before the tool result? Did you match every tool result to its tool use ID? Did you send all results in one user message before calling the API again? Most hangs. Fail one of these 3. 2 stop reason values carry traps that catch implementations that only handle the happy paths. These are the failures from the opening of this video. Trap 1, pause turn. When stop reason is pause turn, the model has paused a long running turn mid-flight. The response you received is partial but valid. The model state is in that response. The correct action: append the response to your messages array as an assistant turn and call the API again. The model picks up where it left off. The wrong action: discard the response and start fresh. The model has no memory of the paused work. Starting fresh means that work is gone. The result will be wrong or incomplete, and the caller will not know why. Trap 2, empty end turn. When stop reason is end turn, but the response has an empty content array or a single text block that is an empty string, a naive loop returns the empty result to the caller. That is a silent failure. Worse, if the loop feeds the empty response back in trying to get a real answer, the model sees empty context and returns end turn again. The loop spins forever. This is the first failure from the hook. The correct guard is simple. When stop reason is end turn, check content before returning. If content is empty, break out of the loop, log the condition, surface an error to the caller. Never return empty silently. Never feed an empty response back into the loop. The unified exam rule: stop reason tells you which branch you are in. Content tells you whether the branches happy path applies. Check both. On the exam, when a question describes a broken agentic loop, identify the stop reason first, then check whether the code handles its stop reason correctly. Loops forever maps to unhandled empty end turn. Lost state maps to unhandled pause turn. Token burn with no. Result maps to missing max tokens exit. The stop reason is always the diagnostic. For the full picture, the 6 agent patterns, how the autonomous loop fits into the broader architecture, and how failure modes compound across long runs. Atlas Episode 1 covers it completely. Link in the description. The next D1 exam prep unit covers hub and spoke orchestration, the coordinator subagent pattern, and context isolation. So that is the whole shape of it. The agentic loop is a while loop keyed on stop reason. Get the branch right, and your agent is reliable. If this sharpened your mental model, share it with one person. Subscribe to AI Tech Book, one exam topic every day. Next, hub and spoke, the coordinator subagent pattern.